So now we're going to talk about linear equations. So when we make a linear regression for two variables, we're going to make a linear equation with one independent variable. So the equation is y equals a plus bx. I'm hoping this looks familiar. It might have been a long time since you've seen it, but that's okay. If you go back and remember y equals mx plus b, that was the equation of a line. Basically, we're doing the same thing, but we're just taking a lot of data that doesn't fit into a straight line and making the best estimate. So, looking at this formula, a and b are constant numbers. In this formula, a is the y-intercept. That means it's where the line crosses the y-axis, and b is the slope. Remember, slope is rise over run, or the change in y over the change in x. X is the independent variable. Remember, that's the one you cannot control, and y is the dependent variable. So typically, you choose a value to substitute for the independent variable, and then you solve for the dependent variable because you're taking the independent variable and you're trying to predict that dependent variable. So remember, the graph for the linear equation for the form is y equals a plus bx, and it's a straight line. Even though I have points that might not be on that straight line, I still need to make a straight line. So any line that is not vertical can be described by that equation. All right, so let's look at 3 examples. Okay, if you're looking at graph A, you can see it's going up into a positive slope. So if your slope is greater than 0, it's going to have this look to it. It's going to rise along the x and the y axis at the same time. If your slope is 0, that means there's really no slope going on, so it's just a straight horizontal line. If your slope is less than 0, and remember in statistics, we're okay with negative numbers, the slope is going to go downwards to the right. Okay, and if you see that here, it's going down.